Hi everyone. Today we are going to finish up chapter 11.3, and that's finding the areas of polygons. And today we are going to use trigonometry and or the rules of special right triangles to find the area of a regular polygon. So we are going to finish up what we started yesterday, and we're going to find areas of regular polygons like this. And that involves us using a little bit of trigonometry. So here, the main difference from our previous lesson is you're going to notice that we are given only the radius of the shape. So now you might ask, well, how does a octagon have a radius? So you're going to have to imagine this as being inscribed inside of a circle. So there is my circle. And we have that regular octagon inscribed in that circle. Now you'll notice that this distance right here, from the center of the figure out to the edge of that circle, is a perfect radius. And that's different from the apothem that we were finding, which is right here. So our apothem is perpendicular to the side, whereas our radius just extends and just kind of gets into that corner of that octagon there. The apothem is right here, and it's right at the midpoint of the side, and it's perpendicular to the side. And you'll notice it doesn't quite reach all the way to the circle. All right, so these are the type of problems that we're going to look at today. So just like yesterday, we're going to start off by taking 360 divided by the number of sides, divided by the 8 sides here, and that's going to give us 45, and that gives us the central angle right in there. Now after we do that, we get that central angle, and it's the angle of that isosceles triangle. We're going to divide that in half, and we will end up with a triangle that looks just like this. So we've got a right triangle here with 22.5 degree angle here, and subtracting that number from 90 will give us 67.5. So just like yesterday, here's our apothem, and this is our side that we are going to call X for the moment. All right, and now I've labeled opposite, hypotenuse, and adjacent, all from this reference angle right here. All right, so a couple of other things to notice, that the hypotenuse is your radius. So that value of that radius is the hypotenuse, and the apothem is the opposite side, and then X is our adjacent side. So we're going to try doing some trigonometry and some SOHCAHTOA. So the first problem here is going to be to find our apothem. So since we're using the opposite and the hypotenuse values here, we write sine 67.5 is equal to A over 8. Now I'm going to go ahead and put a 1 under the sine of 67.5, and then just do a little cross multiplication here. And that will give us a product of 7.391 approximately, and that's our apothem. And as we mentioned in our previous lesson, you want to try not to round too early. If you want to leave a few digits, you don't have to leave all 8 like I did here, but at least 3 or 4 after the decimal place until the very last calculation usually works well. Now to get this side X, we're going to use cosine. So the cosine of 67.5 is equal to X over 8. And then we do the same process as the previous problem. We're going to cross multiply. And we go 8 times cosine 67.5, and that'll give us 3.06 approximately. Now, one thing to keep in mind, that this number is only half of the side that you are looking for. So this value is only half the distance of the full entire side. All right, so that means we're going to have to multiply this value by 2. Multiply by 2. So we'll do that on the next slide because I'm out of room here. So this slide here, we're going to take this value, which again is just half of the side, and we're going to need to multiply it by 2. So multiply by 2, and that's going to give us roughly 6.122, and that's the length of our side. That's our S. That's our side value. Okay, and you'll notice that right here. So it's not X that gets plugged in here, it's the side length, which is this value multiplied by 2. Now the apothem gets substituted just as is, and then we have 8 sides because this is a regular octagon. So once you are done, you should end up with an answer of 181.02 square feet. Okay, so go ahead and pause the video and give this problem a try and check back as soon as you're ready. All right, so we are going to find the area of this regular pentagon that has a radius of 6. So again, I'm going to draw a circle here. I apologize for the very uneven circle here, but I'll try my best to do this free-handed. And you'll notice we have a radius here. The center goes right into the goes right on the edge of that circle there. Again, the apothem doesn't quite make it all the way down. It gets to the midpoint of that figure, but doesn't make it to the circle. All right, so again, we're going to start off with 360 divided by 5 sides, which will give us a value of 72. Okay, remember that's for the purposes of finding the central angle. And that central angle is going to be right in here, 72 degrees, and that occurs throughout the central angle for each of these triangles. All right, it's going to look a little bit something like that. And as always, we're going to take just the half. We're going to just bisect this isosceles triangle right down the middle here. And we're only going to be concerned with this right triangle. This is our apothem. The value down here is really half of S. It's 1/2 the length of the side. And remember that our radius is our hypotenuse. So the value of the radius is the hypotenuse. So we're going to get into our SOHCAHTOA calculation. So hopefully you ended up with something like this. So using the 54 as our reference angle, sine 54 is equal to A over 6. And after cross multiplying, you should end up with an apothem of about 4.854 approximately. Now for the value of x, or the half of the side length, you should use a cosine ratio. So notice everything is the same about these equations except for your trig ratios, and then of course the variable that you are looking for. And again, cross multiplying here results in x is equal to 6 times cosine 54. And that gives us approximately 3.5267. And as mentioned before, this is only 1/2 of the side. So that value is only half of what you really are looking for. So we're looking for the entire side. So we're going to have to double that value. So after doing that, we're looking at a side length of about 7.04 approximately. So let's look at the next side at the next calculation. So our apothem is here, and then here is our half our side length. So when we plug in our side, it's actually about 7.05. So remember, this must get doubled. So we have to multiply by 2. And that's why we end up with 7.05 for our side. So again, right here, This entire side is going to be about 7.053. And our apothem is 4.854, and we have 5 total sides. That leaves us with an area of 85.60 square feet to the nearest hundredths. Let's try out one more problem together, and here it's the area of a regular decagon with a radius of 12. So again, ooh, that circle is really terrible. I apologize for that. I think by now you probably don't need to see the circle, hopefully, so let me go ahead and erase that. But you're given the radius, and you know that because it hits right in that corner here, right where the polygon just connects at that end point there. So you're given a radius of 12. So the calculation will start off with 360 divided by 10 sides, central angles of 36. So we've got 10 triangles here. We have a total of 10 because we have a decagon, and these central angles in here are 36 degrees. So it'll be 36 all the way around. Okay, so on and so forth. All right, but it's that triangle that we're concerned about. One single triangle, and to be exact, half of that isosceles triangle. So we're going to look at a picture that looks like this. When we drop the apothem down, we only want half of that 36-degree angle. And what I'm going to do is, instead of drawing the triangle upside down like this, I'm going to draw just like our normal orientation that we've been using, just kind of pointing upward like this. And this is still our apothem. And again, the radius is the hypotenuse. So the radius of 12 is hypotenuse. And this is our apothem. And this 18-degree angle is complementary to 72. And we have our value of a here that we're going to solve for, and our value of x, which is half the side. So when we do our trigonometry ratios here, or trigonometric ratios, we're going to get sine 72 is equal to a over 12, and cosine 72 is equal to x over 12. If all your calculations are done correctly, you should end up with 11.4126782, and an x value, again, which is half the side, of about 3.708. All right, so again, we are going to double this side length. We must multiply that by 2, because again, it is half this value, which is this value, is only half the value there. So you've got to multiply that by 2. And when you do so, you end up with about 7.416 multiplied by the apothem, that is 11.4. And again, a decagon has 10 sides, just like a decade has 10 years. And if we multiply all this correctly, our final area should be 423.21 square feet. So that does it for today's lesson. If you have any questions, please let me know. And if not, have a great day, everyone.